Hi, I'm Andrew Smith, and I've got the wonderful Bryony and Nitheesh with me again. And Bryony is going to be very much in the role of making sure that Nitheesh and I keep time for this session because there's going to be a lot of demonstrations going on around Packet Tracer. Rather than doing lots of recaps, I think what we're going to do is very much dive in and get on with this and explore why Packet Tracer is cool. Packet Tracer in this instance has been around for almost 20 years now. I saw it sort of early versions, Packet Tracer 1 and 2, but when Packet Tracer 3 came out, and we're about to see Packet Tracer 9, it was a real game changer. And Packet Tracer 3 is like the sort of great grandfather of the Packet Tracer 8 series that we're using at the moment. It's evolved, it's continually evolving, and it's a great and powerful tool to teach networking, cybersecurity, coding, automation, Internet of Things, even sort of basic PC hardware, if that's what you want to do. So obviously what we're going to do, my task, I'm going to build a basic network and explore an algorithm. Um, your teacher's going to do a server with DNS, and I'm going to demonstrate basic routing. So cracking on, and obviously Bryony is going to make sure that we keep to time and behave ourselves. She's going to be there with her watch, going tick tock, you've got 3 minutes, and shut up, Andrew. Yeah, you're going to do that? Tell me to shut up?
I mean, if I've got permission, yeah, I might do it a bit more politely than that.
Yeah, you can try, but hey ho. Okay, so moving on. So in this section, what I'm going to do is use version 8 of Packet Tracer. Why? Because I don't want it to crash in version 9. It is very much in beta. I'm going to get a very um, simple activity. We're going to set up two PCs and then I'm going to just get them pinging each other. And then I'm going to demonstrate Dykstras algorithm and actually show how spanning tree operates. But the important thing is I come across a lot of centre schools and colleges and universities that struggle with teaching algorithms like Dykstras algorithm, like um, finite state machines and many others. And actually, Packet Tracer does it. It runs the algorithm and it runs it in a very visual way, which is quite exciting. So whatever domain that you're actually teaching in, it's probably quite important to get used to using Packet Tracer as a good way of exploring the practical pedagogy, albeit via a gamified simulation environment. Yes, I do know all the jargon for this. So I'm going to bring Packet Tracer into view now and do the can you all see it question. Can you all see? Yeah, Bryony's nodding around. So I've just thrown in a PC, I've thrown in a switch, and I've thrown in another PC. And I'm going to quickly cable this network up. So I'm going to throw in what is known as a straight cable from the PC to the switch. And then I'm going to put in another device that some people miss, and it's hidden within the end devices, a packet sniffer. Because what we're all doing, many of us have used Wireshark, Ether8, Ethereal, and other tools, but obviously in a lot of school and college networks, especially those that use Windows, access to Wireshark is prohibitive because you need admin level access. In Packet Tracer, there is a simulation of the Wireshark environment, and you can actually capture packets from a PC to PC, and yeah, in any sort of segmented environment. So I'm going to just set that up now, and that's coming up and running. The cables are coming out. You can see there's an orange cable there as that switch finally negotiates. And now what I'm going to do is just go into this PC. And actually, I am going to minimize this slightly because I think this is going to be quite distracted if I don't do this right with Packet Tracer. So I'm just going to bring up the other Packet Tracer window and just minimize that so it's easier to see. And now I'm going to go back into this PC, and I'm just going to go into the desktop, and I'm going to set up an IP address. It's not going to be a clever IP address. We're not about proving rocket science, but those of you who've never seen it before, it always puts what we call a default or unsubnetted subnet mask in. I'm not going to put any default gateways in. I don't need to for this activity. And then I'm going to go to the other PC and actually do 10.0.0.2, okay? And exactly the same happens. This isn't clever. I mean, this is really basic. But now, if I actually go into here and do a ping -t, so that's no time out, 10.0.0.1, I'm going to ping from .2 to .1. And it'll start and it's pinging. Wow, I've set up two PCs and they're pinging each other. They're sending ICMP traffic. So if I go to PC0 and actually just go in here and do ARP, which is address resolution protocol, and do a lookup, I can see that the other end is pinging me. And I can even see its MAC address as well. And what's also cool in Packet Tracer, I actually just do a quick Control-C and stop that and go into the physical. I'll actually see if I remember how to do this. Yes, so look, do you see that we've got this MAC address? I'm just going to do a 1, 2, 3, 4 dot, and then got to be careful to get this right. 1, 2, 3 dot A. So I'm following all the rules, and then I'm going to go back into here, hit the up arrow, and set it pinging again. And then if I actually go into here and go into the command prompt and do art-a, can you see? I've just changed the MAC address. So I'm actually able to also emulate a person in the middle attack scenario and packet crafting and actually doing some things that you can actually do at layer 2 of the ISO model within a cybersecurity space as well. Okay, that's clever. Now to prove the algorithm, I've got these pinging each other. PC1 is pinging PC0 forever, and I can actually go into the sniffer and into the GUI, and I can actually see all of these packets sniffing. If I actually look, I can see the spanning tree, the STP spanning tree protocol, Dykstras Algorithm. I can see Cisco Discovery Protocol. I can see the ARPs that I generated. And I can also see the ICMPs, Internet Control Messaging Protocol, or ping packet. So I can actually see this all happily churning away, and it's going to keep churning. And I can actually see the datagrams and the packets, and I can see all the information. So you've actually got the ability to see what's going on, just like Wireshark. Now, I am actually going to go in and I'm going to play with this. So I'm actually going to break one connection. So I'll just go in and I will very specifically, come on, Andrew, it should let me delete this, and it's not giving me the deletion icon. I want to delete a cable. Okay, why won't it let me delete a specific cable? I should be able to delete that cable, and it's not letting me delete that cable. I hate Packet Tracer sometimes when it's there, and I'm trying to do a live demo, and it's not letting me delete the exact cable that I want to remove. Cancel. No, I don't want to delete a specific. I want to delete that cable. Okay, and I have to try and delete. Yeah, I'm going to delete the sniffer because it's faster. Okay, so I'm going to put the switch in, and then I am going to put another set of switches in and create what is called a switching looped network. So I'm going to put in 3 other switches, and then I am going to cable all the switches to each other using crossover cables. And I've got to do it very quickly because of the speed of the way Dykstras algorithm works. But I'm actually going to create a mesh topology, and what you'll discover is that this is actually going to sort out the loops in this mesh topology. It's busy negotiating already. Those orange cables are telling me what is going on there. I'm just going to space it out quite neatly, and then I'm going to connect this PC straight in to this switch here, so it's as far away as possible. So you can still see in the PC, I'm trying to ping, it's doing RTO as a request timeout because I've broken the connection, and you can see Dykstras Algorithm is busy negotiating at the moment, and in a moment this is going to come back up. So I'm just waiting for this to come back up. It should take about 30 to 60 seconds across the whole network as it's negotiated. I could hit the fast forward button. There is a fast forward button here, but here it's come back up again. But what you will see now is that it's built a topology, and it's made one of the switches a root of the tree. And can you see here now we've actually got a rooted topology. But can you see this part is blocked here? So every cable where there is a block, and I would love to be able to delete the. There you go. It's actually brought the right icon. So I'm going to delete that cable because it's got an orange port on, which is a block port. I'm going to delete that cable because it's got an orange. It's got a block port, and I'm going to delete that cable because it's got an orange. It's got a blocked port, and you immediately see the topology, the tree that spanning tree protocol actually built. So I actually threw in a mesh structure, and it automatically blocked the cables, and it's actually built a tree, albeit a weird tree. So let's actually do that. So we all know in networking, all the trees go, the root is always at the top of the tree. I mean, if you wanted to be pedantic, here you go, look, the root is at the bottom of the tree. But I've now actually got this switch network. And Dykstras Algorithm sorted it out for me by actually finding out where the loops were and then prioritizing it for me. Now, this took what was basically 30 seconds and probably more time for me to talk about it than it did for the actual protocol to do. But I too talk to teachers. It's like we talk about Dykstras Algorithm and we're doing it all with pieces of paper, or we're all doing it on a smart board or a whiteboard. Spanning Tree on switched networks has been doing it since the 1970s. Okay, on switched and bridged networks. This technology is actually built to do it, and Cisco used an implementation called Rapid Spanning Tree, and it's actually proving the algorithm that was originally developed by Dijkstra and then applied by Rhea Perlman, and is actually doing it in anger. So basically, you could actually have some real fun with this, and you could build a really complicated mesh, and this would actually build that for you. This isn't a star topology, by the way. This is actually a segmented bus, but you need to know more about how switching technologies work to deliver what is called a segmented bus. But basically, Spanning Tree would now build out that tree and what appears to be a hub and spoke topology. And then there's a whole world of pain when it comes to ether channel. So on that, I'm going to now go back to the slide deck and bring that up, and then hand over to my dear friend and colleague Nitheesh, who's going to start screen sharing in a moment and do a completely different demonstration around how you can use packet tracer to actually teach DNS and how servers and web traffic works. So Nitheesh, are you ready?
Yep, I'm ready. Thank you very
Okay,
much, Andrew.
right, you may start sharing, and I'm going to just start doing some work in the background.
Yep, can you see my screen?
Yes, we can see you clearly.
Yeah. So I'm just going to demonstrate how we can explain DNS as simple as possible for the students. Let me go here and then pick up a server. This would be our DNS server, and then let me quickly go and get a switch on top of it and a PC for us, for the end user to work on. Uh, as Andrew was telling, Sniffer tool is really handy for us using packet tracer. It is very simple rather than using a bit complicated Wireshark, to explain things to our students with a massive packet capture from the network. For simulation, I think for a to start up with for the students who are at schools and level 3 kind of thing. So Sniffer is a really useful tool for us to use. So Andrew used straight through cables, which you can select here. You have console and different cables which you can use as if you are using in a real-time environment. And also in Packet Tracer, we have an automatic connection type. So because Andy used the straight through directly, I will use the automatic one where you can just click on both the devices. It will automatically pick the right cable which you want. Maybe for students who are using it for the first time, they don't know the difference between a straight through and a crossover cable, where to use, what to use. They can start up with an automatic cable connection. And from here, uh, I'm just going to connect to the sniffer, and from the sniffer I'm just going to connect it uh, to my PC here. So just a basic configurations which we want to do. So just go to desktop, uh, give an IP address. So I'm using class C IP address 192.168.1.1. um, I don't set a default gateway for the server here because we are not talking outside the network. Maybe when it is routing in the next bit, um, Andrew will be doing that. So let's go and say that this machine itself will be, this server itself will be our DNS server. And then quickly go to my PC desktop and I say 192.168.1.10. Maybe a bit of an industry best practice, give some 10 IP address or 20 IP address depending upon your network infrastructure. Give some free unused IP addresses which can be statically assigned, and then give the other use the other IP addresses for your client missions, if even you're going to do a DHCP. So here I'm going to give DNS server. So my DNS server, the local DNS server here is 1.1, which is my server. So the moment we do this, what happens is this PC will inform, or this configuration will inform the PC that, hey, this is your IP address and this is your subnet mask, this is your network you belong to, and any DNS query you have to send it to 192.168.1.1. Before we start our DNS basics housekeeping, so ipconfig to check if the configuration is here. Yeah, we can see the configuration. Ping 192.168.1.1, my server. I can ping successfully. The connection is up and running. Brilliant. So the next thing is we go to the server and we try to configure DNS. You can do it in a virtual machine or you can do it in a proper server, but however, it is a bit complicated by here. Um, um, with Packet Tracer, it is quite simple for you to explain, demonstrate it to the students in a very simplistic and easy way. So you can see that the HTTP, these are the different services which a server can offer you in Packet Tracer. Not everything, but at least it has all the basic services which is required. Make sure that HTTP is on if you want HTTPS as well. Um, I'm not going to make any changes here at the moment. Maybe I will do it a bit later. So let's go to DNS. Here is our DNS. Switch on the DNS services, which means your service is on. So what are the record you're going to put in? So DNS is a kind of domain name services, which means it is going to map the IP addresses, the numbers with the names. So what record you're going to create. So here I'm going to create ccst.ou. That is the name, and it has an A record. And to reach this resource, to reach this name, you have to go to 192.168.1.1, which is our server itself because we are using one server. Just add on it. So it means that ccst.ou is a package, is a service which is available at 192.168.1.1. So you type in 192.168.1.1, the DNS server will map you to ccst.ou. If you type ccst.ou, it will map you to 192.168.1.1. Going back to HTTP, if you want to make some changes to your website, or if you want to customize your website, you can go here to the index page. That's the first page which is going to come up. And here you can make changes. So just to fancy what we are doing here, I have already did some HTML scripts. So I'm just going to put that HTML script here. You can use the same one which is already there, or you want to ask your students to create a different one, you can do that as well. Don't forget to save it. I did it a couple of times, didn't save it, my bad. So it's all done. So let's check if things work properly. Uh, I haven't touched the sniffer yet, so we will do the sniffer a bit after some time. Let's go to the web browser in the client, and if I want to access ccst.ou, so I click here, ccst.ou, and I click go. Here we go. Welcome to whatever the content we have is. Just to quickly say, if you are not an instructor yet, write an email to cisco-asc at open.ac.uk. Just in self-propaganda. Right. So yeah, the DNS works. You can see that when you type in ccst.ou, it goes in, it fetches the information from our DNS server, and then it gives you all the information. This is a physical way of explaining it, but are we actually seeing it? Yes, we can see it. So for that we use sniffer tool here. So you go to the sniffer, go to your GUI. You could see that all the traffics between the two devices within that line, within that network, within that transaction is listed here. You have STPs, you have ICMPs, all packets are here. It's a bit sometimes messy because it is capturing all the packet, all the traffics. So I will clear it. And here I don't want all the events to be visible here, because you could see it keeps on all the STPs when there is a request, when there is a traffic, background traffic, it will also be displayed here. So I clear it. I say show none. I don't want everything. Clear everything. Go to edit filters. And if you want ICMP, you can select ICMP. If you want OSPF, whatever you want, you can select it. For now, we are going to demonstrate or understand DNS. So click on DNS, and then it would go back just for the DNS services alone. Because the port here connected from the PC is Ethernet 1, and I'm just going to select port 1 here. The service is on port 1 here. I will and then now I go back here to the web browser, and let me request again my DNS to map my name to the numbers. Yes, it is done. And let's go to the sniffer, and you can see that the sniffer is now having or captured the DNS packet. This is really very useful for you to demonstrate DNS in a simple way, or in a very easy way. So here you could see that you have the Ethernet frame, you have the IP details here. You could see that the source address is the MAC address is 9779, and the destination is 6ED9, which should be the server and the client. If you can mouse over, you could see it is 779, and that's what you see here, which is the source address, which is 779. And if you go here, you could see the destination as 6ED9, and here you could see that it is 6ED9, which means this is the source and the destination MAC address which is being sent in your Ethernet frame. It's layer 2. And then you have your IP, where you have your source and the destination IP addresses, which is 1.10, which is your source, and 1.1, which is the destination. And then
Sorry,
you have,
Nitheesh, that's your
yeah,
time.
yeah, just give me 2 minutes. I'm sorry, when I do the lecture, I go on. So we have the UDP. You could see that this destination port is 53, which is for your DNS, and you can see the transaction goes on well. The same way you can place a sniffer here. Yeah, time is up. I thought of placing another sniffer here, but you can place a sniffer here and see what the server is replying back. The server will also be replying back with 53 port as a source and the as a destination, and vice versa as well. There is one quick change, to make the students critically think. We can do some play arounds in that. So what I'm going to do is, what happens is when there is a name which comes in, the system, the PC will go into the DNS server, and here the DNS server is 1.2. You change it to 1.2, which is not your DNS server, and you go in here, and if you want to try to map it, for some reason, yeah, um, it's under pressure now, my packet tracer, because of the time. So you can see that it is not going, and you can see that there is no DNS packet captured. However, if you just select all, and then you just do it again, you can see there is a ARP request which is going on, which broadcasts things, say that, oh, I never know about 192.168.1.2. I'm searching, I'm broadcasting it, and I'm trying to find it out, and then I'm going to work around that. So this way you can demonstrate students on how DNS works, and maybe allow the students to critically think as well. Thank you very much. Sorry,
Thank you. Thank you, Nitheesh. Thank you for stealing my time. We will have words later. But it's great because you can actually build up complicated DNS domains with Packet Tracer. You can actually set up email domains as well, and actually get them to email each other as part of the way that Packet Tracer actually operates. So you've actually got a degree of complexity. Now I'm going to start my screen share and get back. So now the final demonstration is I'm actually going to build a simple routed network. I've already built it, so I'm going to quickly go around it, but I'm actually going to show how routing protocols actually operate and how Packet Tracer is really good for this. So in Packet Tracer, you actually have static routes, dynamic routes, you have interior routing protocols. It has BGP as an exterior protocol, but only interior. And the reason it doesn't have exterior is BGP is really complicated, and you need to actually really have live routers to do that, and it is CCNP level skills. But you can use RIP, you can use OSPF, and you can use EIGRP and static routes, and actually redistribute between them. So here's one that I built slightly earlier. It's a very simple network where on the left I have actually got it would help if I clicked on the right thing. I've got a 10 dot network, and on the right I have got a 192 dot network, and in the middle I have built a pretend 123 dot network. I'm pretending that this might be the internet. So if I actually now try and ping, so if I ping 10.0.0.1, this should work because it's the local router interface. If I ping 123.0.0.1, it'll work because it's the nearest interface on my local router. But as soon as I start pinging a little bit farther away to .2, it's going to stop working. And that's because routers will route directly connected. So a Cisco router by default, and even your old home router, will route directly connected, but it won't route anything it doesn't know about. And routing protocols are designed to educate. They're a very basic stochastic machine learning. I wouldn't even call them AI, but yeah, you can build up a protocol system where they will learn from each other. You set the rules up correctly, which means that if I try now ping 192.168.0.10, which is the device, here you go, I can't see this. I don't know about it. Where is it? Go away. Stop asking me silly questions. Okay, so we know that that doesn't work. If we actually go inside the routers, So I've actually got, so I've called them east and west. So bear with me a second. It would help if I click inside, enable, and then do show run. You can see I've set up the local interface. So that's pointing at the left PC. You can see I've set up the interface pointing out to the other router, and it's just about as clever as that. If I actually do the same on east, this would help if I just do enable and do show run as well. You can see it's a very, very basic configuration. I've done nothing clever on that, and they are not talking to each other at the moment. So now I'm going to start doing the magic, okay? And I'm actually going to go in and I'm going to configure terminal, and then I'm going to do router. Would help if I learn to type EIGRP 123. And why am I using EIGRP and not RIP? Because RIP is so old that I wish that it wasn't in some national standards. Yeah, Bryony is smiling. She knows what I'm on about. And it's England and Scotland. Yeah, RIP is dead. If you see RIP anywhere, punch the person that put it in there. It's dead. It's long dead. It's Cisco don't teach it anymore. RIP is dead. Okay, it's good only just to teach the concept of hop count and adjacencies. But you're laughing away, Brian. It's horrible.
I'm laughing because I like RIP, because
Yeah.
Exactly why you said, for teaching it's good, and I do feel sorry for it sometimes. That's why
Yeah.
I'm laughing.
Yeah, but it's so legacy.
It is.
Yeah, it should be in retirement now. So I've set up ERGRP, which is a hybrid protocol, and it's a Cisco protocol, but you can get it on open standards now. And I've just called it router ERGRP 1 and I'm going to connect the two adjacent networks. And notice there that I've actually put the network address in. You route networks, not interfaces, unless you're really clever and know how to do smart stuff with wildcard maps. But we don't have time for that level of cleverness at the moment. So network 110.0.0.0 and then network 123.0.0.0. This is the unsubnetted network. And then I'm just going to do write. So I'm just going to write to memory. But I know now that if I still try and ping, it's not going to work. And I'm going to do it again because I haven't configured the other router yet. They're not talking to each other. I've told one router about its adjacent networks, but it's sending out hello packets already, but it's not actually talking to the other side yet, because this side doesn't know that it's being talked to. So I've got to tell it to listen out on the networks as well. Oh, bottom. Sorry, I just hit that accidentally. Anyway, so configure terminal, and then I'm now going to do router EIGRP 123. You've actually got to be in the same autonomous system. So if I did it 124, they won't talk to each other either. They won't exchange that autonomous system number. So now I'm going to do network 123.0.0.0 and watch. It's actually heard the updates, it's heard the hellos. Okay, so it's now there's been the hellos going on. It's been going hello, hello, hello. Oh, actually, you've replied now. So if I actually go to this other device, West, do you see, look, neighbor change. It's up. It's actually heard from dot 2, and this one is saying I've heard from dot 1. Somebody's talking to me. Okay, but that's not the whole story. I actually need to tell the network about 192.168. Learn to type, Andrew. 68.0.0. Otherwise, it's not going to propagate that across the system. And now I'm going to do WR, and I'm going to hit end, and I'm going to do a show IP route. And look, all of a sudden, it's learnt via EIGRP, look, EIGRP, it's learnt via EIGRP, the 10.0. It knows that from afar, it's learnt about the 10.0 network. If I go to this one and do exactly the same, so I'm just going to do right and then do an end, do a show IP route. And you can see here, look, I have learnt from afar about the 192 network. So if I go back to this, go away, try to go and do this and actually go into the desktop here and hit Command Prompt and then hit the up arrow again. Wait for it. It's going to do an ARP, so it might drop a packet. I've got to wait patient. There you go. It's done the RTO. The rest of the time, it's actually done an ARP propagated. It's learned. Now I know where it is, and I now know how to set it. If I do it the second time, all the packets go through, and I could run a packet sniffer and actually see the circulation. But what's really exciting is I can now go to the east router here, and I'm just going to do a conft, and I'm going to do an interface loopback. And loopbacks are pseudo interfaces, so I'm going to do loopback 0. It's brought loopback 0 up. I'm going to do IP address 99.99.99.99, okay? Because it's a great ice cream if you know about it, okay? So we're going to do that one and just do no shutdown for good measure. And then I am going to go into router IGRP123 and then do network 99.0.0.0. Okay, so I've actually created a pseudo interface. We actually use these to test networks and as identifiers for routers as well. So I'm just going to do a do right and end. And now if I go to west and just hit that and do a show IP route, look, it's learned about that network. Okay, really nice, really simple. You can actually show the network running. And then if I go into command prompt and hit the up arrow, obviously now I'm going to change my ping to, and it's pinging that pseudo interface. So you can actually build complex networks and actually show how a routing protocol propagates. And if you've got live equipment, real Cisco routers, you've got 2 really old Cisco routers, this will work. This is exactly how they will work, and it will work in exactly the same way with exactly the same commands. Now, I've deliberately used EIGRP because it was simple and quick to do, and actually RIP version 2 will do exactly the same as this as well. It's just my personal belief is it's a legacy protocol, and this EIGRP is a more up-to-date protocol. Obviously, you can do this with OSPF, but OSPF is a little bit more complicated to configure because of the fact that it will need a wildcard mask to actually set it up on an interface as well. And there are other rules around the way OSPF. But as a basic networking for an absolute beginner, EIGRP is still really easy at getting a quick network up and running, so long as you use the full network .0 address, which is reserved for networks within a IP addressing scheme. So I am going to save that because I'm actually going to put that up on our micro course site soon as a sort of shareable resource, and Nitheesh is going to share with me. He probably will. Can you email me that packet tracer file so that I can share it with everybody as well? So thank you all for listening, and we've got 5 more minutes to go. And basically, you will discover that there is so much more with packet tracer. You can do lots of practical activities with students. You can build complicated networks. You can do simple networks. You can explore all sorts of things in national qualifications. And those of you that know what I'm talking about T-levels or gateway qualifications or GCSEs or A-levels or SQA hires, there is everything in packet tracer. It's going to cover the majority of the services that you are ever going to need to teach. If you're not yet an instructor, I do this call every week. I'm sorry, Nitheesh, I'm doing your slides now. Bryony's used to the fact that I will nick everybody's slides, but that's fine. Just email me and let us know who you are. And everybody that's there so far, we've done or we've given access to, because we've been able to check out who you are and who you work for. And practically, if your organisation is not yet a Cisco Academy, please do apply. But do let us know who you are and where you're from and who you work with before you apply. Unknown applications will get Cisco checking you out. We do need to know so we can A, do due diligence, B, support you, and C, let Cisco know where this is coming from as well, because I think this is quite important. Next week, we're going to start looking at some of the other courses on Netcad that are very, very interesting, and just do some short, brief explorations of them so that, yeah, it's, network and cyber is important, but this is very much a phantasmagoria of other excellent resources that you can all make use of. And if you want to actually enroll on that, I'm just going to put this in the chat now. Obviously, I'm busy emailing everybody all the time and sending updates on social media, but come on that course. And obviously, if you want to access the resources, here is the link for our Netacad course, where we always put up the video, and I'll be putting this video and this session up probably in about the next hour and making sure it's available to everybody. So thank you all. Thank you for being a great audience and behaving yourself. Thank you, Nitheesh, for going overtime and having Bryony tell you off, because that makes me feel so good. Okay, and on that, I am going to stop sharing and stop the recording and ask if there is any questions at this point.